All right, welcome back. So this is Anuj and Alex from Orion talking about desktop. I'm actually really interested in this talk. I'm really glad they presented it. Initially, of course, I was thinking of the traditional containers, Docker server-side stuff. And so when I saw this presentation, I was like, whoa, I hadn't even thought of desktop containers. So I'm super glad this is included. It's a very different aspect on containers. So take it away, Anuj.
Cool. All right. Just a quick note. Can everyone hear me? Yes. Great. Beautiful. All right. So today, this talk is the future of the desktop is on hypervisor-powered containers, and this is the Containers Mini-Conf at linux.conf.au 2020. Cool. So who are we? My name is Anuj. That's Alex and Andrew, and we are from Orion VM. So essentially, what we do is we have a cloud. We provide the cloud to you, and you can resell the cloud under your own branding. So we've been using Qubes at work for dev and sysadmin work for about 2 to 3 years on average, and that's why we know about it. So what are we going to be talking about today? Today we're going to talk about, well, what is Qubes? What makes it a secure and usable desktop? How does it compare to containers in terms of implementation? And then we will do our best to answer any questions that you might have. So first off, the tagline for Qubes is that it's a reasonably secure operating system. And the point of it is that it focuses on security by isolating things. So an individual qube is either the building that's opposite the convention center that some of you might have seen, or it's the Zen domain that's running an operating system like Linux or FreeBSD. Now, these are tied together using Vchan, which we'll talk about shortly, and standard Zen networking. And it also has functionality, again, through Zen, for isolating both USB and PCIe devices into one or many qubes, but mainly one. Finally, there is a some software that allows you to control and run qubes, and it's the QRexec protocol. And again, this is done through Vchans. So first up, there's a screenshot. You might notice this is a very, very standard sort of Xfce session on the right, i3 session on the left. So Qube supports both of them, and it's generally it's probably what you're expecting for the most part, with the exceptions of all the colors and the big bars at the top. So the point of the big bars is to tell you, for one, you'll be able to see a name in the top corner, and that tells you which qube it's running in. However, this sort of thing has to be stitched together in some way. So here's another example. We have a login for our website, and then password manager. You'll notice one of them is in a vault qube, and another is in a disposable qube. And essentially, these have to be, we have to have a way of printing this out in some systematic way. So this is the GUI system, and there's a lot there, so let's go through it bit by bit. So when Firefox is running inside of a domain, so it's running inside a virtual machine. So we need to get, what we need to do is Firefox will send Xserver commands to do its rendering and updating. Every qube has its own Xserver, and that Xserver will then, so Firefox will send its stuff to the Xserver inside a qube, and then that Xserver will render an image in a shared memory, in a memory region that is shared with DOM0. So DOM0 is the management or the admin virtual machine. So once the image has been generated, what will happen is that a client in the DOM0 will see that it's there. It's called GUI, a daemon, yeah, a GUI D will see that. It will take that image and then forward that to the Xserver in DOM0. So essentially what this allows you to do is you can stitch together programs that are running in separate virtual machines into one unified desktop. So here's an example of that. On the right, we see this is the view of the Xserver from the Vault qube. That is the view of the Xserver from the disposable qube. And this is the unified view that you as a user will have that is stitched together through that system. Cool? All right. So what we didn't really mention before was how do we get input into these systems? For example, if we actually want to go to that website over there, someone has to do some typing. So the way that happens is that your mouse, the Xserver inside DOM0, will know where your mouse is. And based on that, it will focus in on whichever window that you're mousing over. Now, because of that sort of GUI D that I mentioned before, each each cube that isn't the management cube has its own individual connection to the DOM0. So because of that, the DOM0 can know which window that you're mousing over and then forward any input commands over the shared memory channel to the X server of the application that's running, and then that can then be further forwarded to the application itself. All right. So the next thing is Vchan and Qubes RPC. So Vchan is a peer-to-peer pipe between cubes, but also, in a simpler explanation, it's a Unix socket between these two virtual machines. So they're generally the remote procedure calls used for access control, which will come up an example when you talk about how we might want to do SSH. So here we have split clipboards. So normally, you would just copy from there, paste in there, good to go. However, because there are there's X servers in each cube, they have their own clipboards. And because they have their own clipboards, that doesn't really work. So you could have a global clipboard. However, the problem with that is then if you have sort of a malicious program, it could then try steal whatever's in that buffer. So in order for you to do a copy-paste, you have to explicitly copy something into a global buffer. And that can be done not using that. I don't have that slide anymore. Cool, all right. So you can do that by doing Control-Shift-C, which will take that password there into a global buffer. And then if you want to paste, you have to find out where you want to go, Control-Shift-V, and that will overwrite the clipboard buffer in the cube that you want. And you can paste that in like normal. So finally, we want to, for the RPC stuff, we want to talk about vault isolation. So you might have a work cube, and you want to access some server, and you want to do SSH. However, we don't actually store our keys in our work VM. They'll be stored in our vault VM, which we'll later find out is somewhat isolated. And the work VM, what it can do is it can start up the SSH connection with the remote server, and then when it does that, the server will send the challenge. Then what you can do is you can take that challenge and forward it over the Vchan to our vault VM. The vault VM can solve the challenge and then send back the solution to the challenge of the Vchan without the key ever having to leave the vault. So now that's nice. However, we also want to, when this process happens, before it can go through, it has to be approved by DOM0. You, as a user, will be prompted to approve this operation. So there cannot be someone that, any VM that cannot access the vault without you explicitly knowing about it. All right, so now let's move on to networking. So generally, cubes have, the way that they're set up is a cube can either consume networking or it can provide networking. And it can also do both. So here in this particular example, sysnet will provide networking to sysfirewall, which will then provide networking to the rest on the right over there. To your left, right. So then you might notice at the bottom left-hand corner over there is our vault VM. It neither provides nor consumes networking. So it's essentially isolated by the network from here. To dig into the details a bit more now, we want to see how this actually works under the hood. So generally, the communication between two cubes is using the Xen PV network interface. And essentially what this is, it's a point-to-point communication channel that uses shared memory. And essentially what happens is when a connection is established, at each endpoint, two virtual interfaces cards are made. And from inside the cube, it looks like a standard networking card. When you send a packet to it, it will be copied into the shared memory region, and then the other card will see that, copied into its own memory region, and that will be passed along as it needs to until it hits, in this example, sysnet, which will then actually contact the physical driver and then send that packet off. Now, in this process, inside each of these cubes, you can have IP tables, firewalls, NATing, and routes as standard. So you can build up pretty complex network topologies. But this is built essentially using Xen technology. Just as a quick note, it's important to note that the things that are copied between them are Ethernet packets. And the way these can be copied pretty fast, at like 10 to 15 gigabits between them. So it's still fast enough to deal with the NBN. So now going to containers, in this containers talk, this is an example of how you might, this is might be able to see a very similar setup. Right, so in this case, there's not necessarily a common setup that you might have, but we sort of want to focus the principles here, and also we don't really have time to set up the graphics for this one. So here, what we have is, we want to sort of, we have network namespaces, and what network namespaces are is that they are they're sort of groups of processes that have access, that can see particular resources, specifically interfaces, IP tables, and routes. And when you want to set up a communication channel between two containers, what you do is you create a pair of virtual Ethernet devices and put them into separate namespaces. So now container A, and which sees interface A, will not be aware of interface B necessarily. All right. So moving on, then we can talk about storage. So when we want to make a new Qube, we want to start running a new VM, it has to get its storage from somewhere. And in this case, on the disk, we have LVM, and in that LVM, we have a volume that is the template for that. In this case, it's Fedora 30. And generally, you can install Debian without much issues. And when it starts up, what you'll do is you'll take Qubes will take a snapshot of that thing, and any of that volume, make another one, and any writes to the root directory will, instead of going to the template, will go to this snapshot. Also, because we need more than just a root directory run, if you want any persistent storage, it will create a new volume for persistent storage, which will be work private as seen there. Not shown in this diagram is a volume that will be created for kernel modules, and a volume that's also created for swap space if required. All right, so moving on. In contrast, as opposed to doing things at a volume block level, we instead want to do things at the file system level here, where now instead of having blocks that you create, you have a template, and then you sort of overlay over that template, where you make a folder, use unionfs, and then any writes will go to the folder instead. The nice thing about containers is that you can sort of layer the templates. So you can have your sort of maybe your Fedora user space, an application on top of Fedora user space, and then anything else you might want on top of that. So in this case, if you want persistent storage, you'll have a folder, and you'll use mount bind for that. So one of the consequences of how Qubes does storage is the fact that Qubes can have disposable Qubes, disposable VMs. So essentially what these are, as soon as you close this Qube, all the persistent storage is deleted. Not erased, deleted. So what this is useful for is if you have a document that you are sent that you don't trust, you can open in this thing, look at it, and close it without having to worry that you got attacked through an error in the PDF parsing or whatever. So this is somewhat similar to like stateless containers, but it's applied to a specific desktop use case. Moving on, so the next thing we want to talk about is memory. So each Qube has a dedicated resizable memory. So generally, you have an initial memory of like 400, and it scales up as you need it, but you can change the initial and the max as you need. Memory generally moves between Qubes, and there is a daemon which sort of runs once in a while, and it will move stuff, but it's generally not that fast. They generally won't move stuff very often. Communication is done over sort of the small amounts of shared memory, which are those Vchans we mentioned before. And essentially, it'll be a few megs that are used to copy stuff around. Containers, on the other hand, have the shared pool memory. That's sort of whatever the C group says, this is your limit, that's sort of what you have. And because it's sort of, you don't have to go down to the Zen in order to rearrange the memory stuff, and you're all working at the kernel, the memory can be rapidly circulated around based on the demand. Finally, this is way more efficient. However, for example, if you have two programs that are running in the same control group and that's being cached, that might open up some side channel vectors. All right, so here we have an example of a tool that we can use to run, start a Qube running. So here we have qvm run, And I'm not entirely sure that's visible, but you can, basically what happens is there's a listener on the side of the cube. You can send it commands, it will run those commands, and then it will send back whatever the standard out was. So here, just over there, we run who am I and hostname, and it's used by the GUI in order to start up FreeCAD over there. As a note, you can see the cubes also run Steam and Factorio. Oh, crap, sorry about that. Moving on, so you also have QVM copy to VM, which this is essentially a way to copy something to a virtual machine. And the containers equivalent of this is basically CP. You're good to go. Just going back here quickly, the way you do something like this in sort of container land is your Docker run and the like. Here's where I'm going to pass off to Alex, and he will tell you about how, if you could make a cubes using containers.
Oh, thank you much for that. Quick mic check. Can everyone hear me? All good? Sweet. So, obvious question that you may have thought of, given that you're all container-minded people, this container mini-conf. So, this cubes thing, it looks kind of cool, but can it be made out of containers? And the answer is kinda. There are some existing projects that work reasonably well and that are built using containers and container primitives, specifically looking at Subgraph OS. The issue there is you're still sharing a whole bunch of kernel objects. You're still sharing the same kernel. And you don't have access to things like the IOMMU, which, as we should all know from the talk yesterday, is the firewall for PCIe. So, for example, if you're being attacked through malicious Wi-Fi hardware or the like, which is becoming more and more prevalent, there is nothing really to stop, for example, that Wi-Fi card from just reaching in and stealing your SSH keys or what have you. You're also dealing with just the sheer size of the Linux kernel. It is incredibly large compared to the much smaller surface area of Zen. So Zen is the hypervisor used by Qubes. It's a microkernel sort of architecture. So finally, if you're looking to go and run Qubes by yourself, well, back at home, you need to know, well, is this actually going to run on my hardware? That HCL there is the hardware compatibility list. So if you already have like a laptop or whatever it is, you can search in there to see if other people have it running, if there are any tips and tricks that you need. If you're looking to buy something new, there are actually quite a few vendors who will go and sell you hardware that not only will run Qubes nicely, but will also run secure firmware. So specifically that core boot / heads over there. As an aside, there is a core boot BOF. You should go to that if you think that's cool. So core boot is kind of like Linux for your firmware. And heads goes and includes TPM-style security to protect against what are known as evil maid attacks. It's very interesting. You should Google both of those using DuckDuckGo, of course. And then finally, you'll see, for example, ThinkPads and the like, which is a common sort of staple amongst sysadmins or developers in general. You can reflash those ThinkPads to run core boot or what have you. Otherwise, they do run well out of the box. But the only thing to keep in mind is recent AMD CPUs, you do have to be a bit careful in terms of kernel support. And as we mentioned earlier on, because Qubes uses essentially a pooled memory model where each cube is basically just given a chunk of RAM and it doesn't really recirculate, it chews up RAM reasonably quickly, especially if you have a bunch of different cubes doing a whole bunch of different things. So giving it, well, 32 gigs is generally overkill, but you definitely don't want to be using it with less than 8, for example. Like 8 generally runs fine, 16 is definitely recommended. Next. So, as we've been using Qubes from sort of a commercial point of view for the last 3-ish years, we've found a lot of really good parts about Qubes, a lot of things we really liked. There are a lot of things that we went through and used and we're like, hey, this would be really cool if it could just do this. And now, like, I can almost see you guys going through and saying, well, it's an open source project. Why don't, like, pull requests accepted? Yes, that is true. Unfortunately, we don't really have the time for that. But if anyone else around here is interested in these sorts of things, we can come and talk during the BOF to see if we can find a critical mass to see if we can get this actually built. So specifically for the containers talk is container style integrations. So Qubes at the moment is very much a single user sort of desktop experience. It is reasonably easy to build your own custom cubes. It is reasonably annoying to go and share those with your colleagues and what have you. Being able to do the standard sort of push, pull sort of commands would be incredibly useful. And from looking under the hood, it should be reasonably simple to implement. Mostly because Qubes in and of itself is not much of a monolith. It's made of a bunch of building blocks, and it builds itself out of these building blocks. So for example, there's a really nifty feature called Convert to Trusted PDF that is built on top of disposable VMs. So it uses itself, which makes it easy to extend. Also, having Docker file style generation of these cubes and the like is useful, especially if you're looking for reproducible and trustable builds. And as a security-related project, that is a very useful thing for cubes. And that final thing in terms of stackable templates, like as everyone here would know, because if you've ever used Docker or what have you, and you've tried to pull in anything that's any amount of complexity, you've noticed that all of your images are full of a whole lot of different layers coming together to actually provide the final thing. As we mentioned earlier on, with the way the cube storage works, you don't have that multi-layer capability, and modification there would be very useful. So, continuing on. SRIV GPUs. So SRIV is a very interesting thing whereby a PCIe card can go through and say, I'm not just one PCIe card, I'm actually 24 or what have you. And then each one of those subcards can then get passed into these cubes. And so previously you saw Qubes running Factorio, but the real question is, can it run Crisis? And the answer that I want to have is yes. And with SRIV GPUs, I think that is very doable. Then as a final sort of thing, looking to go through and integrate Qubes more into the cloud. Like, yes, we're a cloud computing company. Yes, that's a little bit interesting. But as a more general point, we think that having things like a secure zero-knowledge backup and restore, so you can go and back up your Qubes into the cloud, and then if your laptop gets run over by a bus, you can go and restore that onto a new one. Like, that would be incredibly useful to have. And it's, again, not particularly difficult to build, but it's not there. Similarly, having enterprise support and having the ability to go through and pay for that would be useful as a Red Hat style model. And finally, Qubes OEM to make it simple and easier for hardware distributors to go and sell you a laptop or a desktop with Qubes pre-installed that does things like, for example, generating your full disk encryption keys as you actually turn it on for the as you turn on for the first time, and having integration there with the TPM. And finally, help is wanted. It is an open source project. Have a look at the Qubes issues for places to start. If you're looking for more info, there's a BOF Thursday at lunch. There's a talk from yesterday, and there's some links. Thank you very much. Any questions? Oh, okay then. Yep.